Right, welcome. Let's go to our integrals. Okay, so integrals are very important in electrical and mechanical as well as civil engineering calculations. It's actually used vastly in all sorts of industries, both for computing and for actually calculating some sort of areas. So for our side setup, we're going to just use a rule that says if I am going to integrate um, x with respect to x, the integral is x to the power of n plus 1 divided by n plus 1 plus our constant c. So let's take an example, the integral of 7 dx. So as we apply the rule, this is the same thing as 7 the integral of x to the power of 0 multiplied by dx, which is 7 multiplied by x to the power of 0 plus 1 divided by 0 plus 1 plus our constant c, which will give us 7x all to the power of 1 plus our constant c. Okay, so that's a basic one that we typically get to integrate our sessions. Let's take a second one. Let's integrate a number of terms together. So let's start with 2 over x to the power of 3 plus 5 over x to the power of 2 plus, let me make it negative. Let me make this one negative 7 over x plus 14. So we've got a sum of different numbers being integrated. So essentially, this is the integral of each separately. So we have to rewrite this as a negative dx plus 5, the integral of negative x to the power of negative 2 dx minus 7, the integral of 1 over x plus 14 dx. Let's just squeeze in dx quickly there. So let's say dx, and then plus 14, the integral of 1 dx. So we've got first term, second term, third term, and fourth term. Right. So as we integrate, we can rewrite this as 2x to the power of minus 3 plus 1 over minus 3 plus 1. That's going to multiply there, plus 5 times x to the power of minus 2 plus 1 divided by minus 2 plus 1 minus 7. So the integral of 1 over x is the natural log of x plus the integral of a constant term. It's 14x plus c. Then we are required to simplify out. So we'll get 2x to the power of negative 2 over negative 2 plus 5 multiplied by x to the power negative 1 divided by negative 1 minus 7 the ln of x plus 14x plus c, which will give us a negative 1, right, divided by x to the power of 2. So we are writing the power as a positive power, and then we have not plus, that's negative 5 over x minus 7 ln of x plus 14x plus our constant c. Okay, these are typical questions that we can get, and that's one of the ways that we can solve them. So I wanted to also add a question where we can play around with the type of question that you need to integrate first. So let's take one. Let me go towards the left. That would be much better. Let's take number 3 as an example, where the integral that is required is of the following. So we've got, let's integrate the square root of, let's say, e to the power of t 2t plus 2e to the power of t plus 1 dt. Okay, so on this type of questions, what we are required to do is to first try to break down this said form, right? So we've got a square root of a number of terms underneath. So we look at what can be done on those terms. What is easier to look at is that we will have to find factors. So let's look at factors. So e to the power of t and e to the power of t can be factors of the first term multiplying together, and the last term, the multiples of it is 1, and we can say this is positive and that is positive. So e times e is equals to e to the power of t times e to the power of t gives us e to the power of 2t. E to the power of t times 1 gives us e to the power of t. Another e to the power of t times 1 gives us another e to the power of t. So when you add those two, that will give you a middle term. 1 times 1 will give us 1. So our factors are correct. Okay, so let's continue. So we're going to integrate. These are two brackets, so we can rewrite this as e to the power of t plus 1 all to the power of 2 with respect to t. And then that square root will fall off. So I'll have the integral of e to the power of t plus 1 like that with respect to t. And we're going to integrate each term separately like the one that we did next to each other, remembering that this constant 1, so this is, let me just use a red pen, this is the integral of e to the power of t dt plus the integral of e to the power of 0, right? Yeah, e to the power of, let me just rewrite it like this. So it's 1 dt, Okay, so 1 dt is the same thing as t to the power of 0, and then let's continue. The integral of e to the power of t with respect to t gives us e to the power of t. The integral of a constant 1 with respect to t will give us t plus the constant c. Okay, I hope you find this very, very interesting. Check me on the next video, where I'm going to now get into integrating standard functions that presents themselves as disguised form. Okay, cheers, bye.